Hello, I am Dr. Suman, and today we shall be studying about the mechanism of conduction of a nerve impulse. So, what is a nerve impulse? It is a result of chemical, mechanical, and electrical disturbance that is transmitted along a neuron. The four stages are polarization, depolarization, repolarization, and a very short refractory period. Now, if you see the axon, if this is the axon, we have various gates and channels on the axonal membrane. So this is sodium potassium pump. It allows influx and efflux of both sodium and potassium ions. This is sodium channel, voltage gated. It allows influx and efflux of sodium ions only. And this is potassium channel for movement of potassium ions. Now the fluid inside the axon, here the fluid inside, this is called exoplasm. Outside it is called extracellular fluid. Now in the ECF you can see there are both sodium and potassium ions, but the concentration of sodium ions is more than the potassium ions. Now in the exoplasm you can see there are sodium ions, potassium ions, and P means proteins, but then the concentration of potassium ions is more than the sodium ions, and the proteins present, they are negatively charged, right? So the permeability of the axon also is different. It is more permeable to potassium ions, almost impermeable to sodium ions, and totally impermeable to proteins. That means proteins cannot move out of the axon. They will stay in the exoplasm only. It is only sodium and potassium which can move in or move out. That is influx and efflux of sodium and potassium ions. Now let us study the first stage. This is seen in an unexcited neuron. There is no impulse. So this works with the sodium potassium pump. There is influx of 2 potassium ions and efflux of 3 sodium ions, right? So as a result we'll have an axon which will have positive charge on the outside because there's more sodium, and negative in the exoplasm. So due to the difference in charges between the outside and inside of the membrane, a polarized state is created, right? And the potential present here is called your resting potential, right? Okay. Now after this we have the depolarized nerve. Now in the depolarized nerve, sodium gate or the channel will open up and there will be influx of sodium ions. So this sodium channel will open up, there will be influx of sodium ion. So what will happen? There will be negative charge on the outside and there will be positive charge inside the axon. This happens after the impulses on the axon. Next we have repolarization. In the repolarization, sodium gate closes and the potassium gate opens. So what will happen? There will be efflux of potassium ions. So here sodium gate is closed, the potassium gate will open up and potassium ions will move out. So what is the net result? There will be positive charge on the outside and negative on the inside after the repolarization. And this is similar to the polarized state. But the ionic distribution in this stage is not similar to the polarized state. So the original ionic distribution has to be restored. And this is happening with the refractory period, in which sodium potassium pump will work again. And it will lead to the resting potential or the polarized state, which was the first stage we had seen, right? And this is a very short period, refractory period. So let us summarize all the stages. First is the refractory period. First is the polarization. In polarization, sodium potassium pump will work. There will be efflux of 3 sodium, influx of 2 potassium, and the potential developed is called the resting potential. Then we have depolarization. In depolarization, sodium channel will open up. This influx of sodium ions and it creates an action potential. Remember, depolarization is related to the action potential. At the peak of the action potential, then we have the repolarization, in which potassium channel will open up, closing of sodium channel, opening of potassium channel. There will be efflux of potassium ions and it will help us to go back to the polarized state. So with this we come to the end of this mechanism, and I hope it has been useful to you. Thank you.